Folks, I'd like to provide you with a little hint on problem 5. A few folks have asked me for a little help, and here's a hint, okay? What I have open on the right is our simple complete simulation exercise, which was based on the Poisson distribution. You can see here that I generated a cost and a price for the scooters, and I have two important columns here. This column, cost, and many costs. And you notice that they're the same. It's just that there are fewer over here that are included than what you see here. Why? Well, because I don't know how many particular arrivals there are going to be, and so I generate many, and then I say, okay, when you get to the point where you've gotten at least 8 arrivals, stop counting, everything else turns to 0. So this blacked out area here is conditional formatting for everything in there is 0. Then of course I'll add this column of numbers here. The same thing is going on in this workbook, which is problem 5. I've switched the cost and many cost. The many cost is going to be in this particular column, and then I will place a statement just like I did over here. If you look at the function here, it says count only up to the point where you've got as much as the index. The index is going to be the actual failure rates that you sample from the Poisson distribution and place here. Now, you're not going to have just one table of Poisson values. Why? Well, because we have numerous arrival failure rates, average arrival failure rates, and they're 1, 2, 3, and 4. So you'll have 4 tables in your Poisson sampling, and you'll need to know which one to go to. You can use an if and say if this value, if the average failure rate is something here, then go to a particular table. If it's not that, then go to another table. If it's not that, go to another table. So you wind up with tables that here we had 1 in our complete problem. You're going to want to wind up with 4 of them here, and you can calculate in this cell the index function with the embedded ran between functions also. So what you're going to wind up with here are many actuals, and then up to the number of sampled Poisson arrivals. Of course, all of that leads to totals down here, a total for a 3-year cycle, and then the total for the for both vans here, and we're done. So you need to calculate for each one of these 6 columns, van 1, year 1, van 1, year 2, etc., by simply sampling from the appropriate table given the failure rates associated with a randomly selected number of demands. Where does that come from? Well, we have a demand. If it's 2,500, if we select 2,500 randomly, then it's going to be 2. And of course, these values come from a discrete distribution. Here's the discrete distribution. So you'll have to turn that into a cumulative distribution to sample those values. All right, I hope that helps with the problem 5 of the advanced workbook in module 4.